This is my second video lesson for the unit periodic table. In this video, we will start analyzing different trends on the periodic table. We're going to start with reactivity and metallic character for this lesson. So let's go to page 7 in the class packet. Motivation. What is the trend for the nuclear charge across the period? Nuclear charge, if you recall, is the charge of a nucleus. So before we answer this question, let's read the learning target. At the end of the lesson, I will be able to explain the reactivity and metallic trends on the periodic table. There will be a homework number 2, which will be a Junopod, based off this lesson. Nuclear charge is the total charge of the nucleus. Basically, it's the number of protons. For example, lithium has a nuclear charge of 3. Fluorine has a nuclear charge of 9. So as atomic number increases, does the nuclear charge increase or decrease? So based on period 2, you can clearly see it's increasing. So next, we're going to talk about the shielding effect, which describes the attraction between an electron and the nucleus in any atom with more than one electron shell. So let's look at this diagram. If you recall from theme number 2, opposites attract, same charge repel. So all these electrons will be attracted to the nucleus, but these electrons will also repel each other. So the inner electrons will repel the outer electrons, and vice versa. So the outer electrons sort of feel the nucleus less than the inner electrons. The reason for that is because the inner electrons are sort of blocking and shielding the nucleus attraction from the outer electrons. So they feel what we call a shielding effect. The attraction they feel from the nucleus is less than that of the inner electrons. What the outer or valence electron feel is called effective nuclear charge, which is the net charge or attraction felt by the valence electron. Nuclear charge is the atomic number, and the shielding electrons is the number of inner electrons. So keep in mind, the outer electrons will feel the nucleus less than the inner electrons. So to calculate it, you have to subtract the atomic number from the inner electrons in the atom. So let's do a small practice. I want you to calculate the effective nuclear charge of each element in period 2 and in group 1. Pause this video and resume once you're done this. Okay, so here's the answers for period 2. So what pattern do you notice? The effective nuclear charge increases across the period. Now for group 1. Now, what pattern exists here? Notice that the effective nuclear charge is constant. It does not change. So across the period, it will increase, but within the group, it will stay the same. Learning check number 1. What occurs as the atomic number of the elements in period 2 increases? Pause this video and resume once you have the answer. Okay, so this is based off what we just did, so the answer is choice 3. So keep in mind, nuclear charge means atomic number. So if the atomic number is increasing across period 2, nuclear charge should also increasing. Electron shielding is the inner electrons. If you look at period 2, they all have the same number of inner electrons, which is 2 inner electrons. So the best answer is choice 3. So for each trend that we're going to talk about in Unit 4, we will be using the effective nuclear charge and the shielding effect to explain each one. So we're going to start with reactivity trend. For nonmetals and metals, we're going to start with nonmetals first, predict how the reactivity of nonmetals changes as you move across the period. So here I have diagrams of period 2 nonmetals. So when nonmetals react, what do? They gain electrons. They become anions. So the more reactive your nonmetal is, the faster it becomes an anion. So we are going to ignore the noble gases because they do not react. So here is an analogy. So this metal ball represents an electron. The magnet represents the strength of the nucleus. If we compare these magnets over here, which one has the stronger attraction for the metal ball? That would be this magnet over here. Why? Because it's bigger and stronger than this magnet. If we apply this analogy to these elements over here, which of these elements has the bigger and stronger nucleus? That would be the fluorine, because fluorine has a greater nuclear charge than these elements. If we were to calculate the effective nuclear charge, fluorine would be 7. 9 minus 2 inner electrons would be 7. Oxygen will be 6. nitrogen will be 5, and carbon will be 4. So you can see the effective nuclear charge increases across the period. So fluorine has the stronger effective nuclear charge. So in addition, notice that the shielding effect is the same for each element, right? So they have the same number in electrons, which is 2. So since it's constant, it's not going to play much of a role here. So based on this analysis, the reactivity trend for nonmetals should increase across the period from left to right. So to summarize this, it is easier to gain electrons with a stronger effective nuclear charge, and the shielding effect is the same across the period. So the same number inner electrons. Now we're going to talk about the reactivity trend for nonmetals within a group. Keep in mind, when nonmetals react, they become anions. They gain electrons. So we will be applying the same strategy. We'll be comparing the effective nuclear charge and shielding effect. So let's look at fluorine and chlorine in group 17. What is the effective nuclear charge of fluorine? It is 7. 9 minus 2 is 7. How about chlorine? It is also 7. So this means that the effective nuclear charge is the same for both elements. That means the attraction felt by the valence electrons is the same for both elements. So imagine that they have basically the same size magnet. Okay, so how about the shielding effect? Fluorine has 2 inner electrons, while chlorine has 10. So which element has the strongest shielding effect? That would be chlorine, because it has more inner electrons. So which element will have an easier time gaining an electron? So fluorine will have an easier time attracting an electron. Why? Because the shielding effect is weaker in fluorine than in chlorine. In fluorine, it only has 2 inner electrons, while chlorine has 10. There's less competition for the nucleus in fluorine than in chlorine. Based on this analysis, the reactivity for nonmetals should increase as you go up a group. So to summarize, less shielding or inner electrons helps attract an electron, and the effective nuclear charge is the same within a group. So if we look at the trends for across the period and within a group, fluorine is the most reactive nonmetal. So in every trend that we talk about, always consider the shielding effect versus the effective nuclear charge in order to explain the trend. Running check number 2. Which nonmetal is most reactive? Pause the video and resume once you have the answer. Okay, so the answer is fluorine. Choice 1. Running check number 3. Which element is least likely to undergo a chemical reaction? Pause this video and resume once you have the answer. Okay, so the answer is 4, neon. That's a noble gas. Noble gases don't react. So now we're going to talk about the reactivity trend for metals. Predict how the reactivity of metals changes as you move across the period. So we're going to move from left to right. Unlike nonmetals, metals tend to lose electrons. When they react, they become cations. So the more reactive your metal is, the faster it becomes a cation. So to determine the reactivity of metals, we have to compare two factors, the effective nuclear charge and the shielding effect. So let's start with effective nuclear charge. What is the effective nuclear charge of lithium? It is 1. 3 minus 2 is 1. How about beryllium? Beryllium is 4 minus 2, which is 2. So based off of this, lithium has the weaker nucleus. How about the shielding effect? Both elements have 2 inner electrons, so the shielding effect within a period is constant, so it shouldn't play much of a role here. So based off of this, which element will have an easier time losing an electron? That would be lithium. Why? Because lithium has a weaker nucleus. So the reactivity trend for metals across the period is that it will increase from right to left. So just to summarize, it's easier to lose an electron with a weaker effective nuclear charge. The shielding or the number of orbitals is the same across the period. Now we're going to predict the reactivity of metals within a group. Keep in mind, when metals react, they become cations. They lose electrons. So we're going to ignore hydrogen because that is a nonmetal. So let's look at lithium, sodium, and potassium. So to figure out the reactivity of metals, we need to look at the effective nuclear charge and the shielding. What is the effective nuclear charge of lithium? That would be 1. sodium is also 1, and potassium is 1. So the effective nuclear charge is constant within the group. This means that the strength of the nucleus felt by the valence electron is roughly the same for each element. So now let's look at shielding. So for lithium, it is 2 inner electrons. For sodium, it is 10. And for potassium, it is 18. So based off of this, which element has the strongest shielding effect? That would be potassium because it has the most inner electrons. Based on this analysis, which element will have an easier time losing the electron? That would be potassium. Why? Because potassium has the strongest shielding effect. It has the most inner electrons. The valence electron of potassium has so much competition for the nucleus. Another way to think about it is if you look at the valence electron, it's on the 4th energy level, while sodium is on the 3rd, and for lithium is on the 2nd. So it's much easier for potassium to lose an electron than sodium and lithium. So the trend for the reactivity of metals within the group is that it increases as you go down. So to summarize, the more shielding or shells or electron repulsion, it helps lose an electron easier. Effective nuclear charge is the same within a group. The most reactive metal is towards the bottom left of the periodic table. Now I want you to watch a video about the reactivity of group 1 metals. The link to the video will be in the descriptions. Once you watch the video, you can resume this one. Learning check number 4. Which element is more reactive than calcium? Pause the video and resume once you have the answer. Okay, so based off the reactivity trend for metals, it should be potassium. Choice 1. The reason is because potassium is to the left of calcium. Learning check number 5. The least active metal of those represented below has an electron configuration abbreviated as what? Pause this video and resume once you have the answer. So first, you have to look up which elements are these on the periodic table. Once you do, you find out that these are all group 2 elements. And since it's asking for the least active metal, it must be towards the top of the periodic table. So that would be choice 1. Now we're going to talk about the metallic character trend, which refers to the level of reactivity and properties of a metal. The higher the metallic character, it means it's more reactive metal. So it has the same trend as the reactivity of metals. So that means it increases from right to left and top to bottom. You can think about it this way, the metals are on the left side of the periodic table, while the nonmetals are on the right. Sometimes on the regions, they'll ask about the nonmetallic character trend, which refers to the reactivity and properties of a nonmetal. So it basically is the inverse of this trend. So for nonmetallic character, which referring to nonmetals, you'll be increasing from left to right and bottom to top. Learning check number 6. Which element in group 15 has the greatest metallic character? Pause this video and resume once you have the answer. The answer is 4, bismuth. The reason is because bismuth is a metal. Nitrogen and phosphorus are nonmetals, so they won't have a lot of metallic character, and antimony is a metalloid. So the best answer is bismuth. You can also figure this out by using the metallic character trend. So this concludes the video lesson for today. Remember to do the Junipod homework.